In the last video, we talked about multiplying rational numbers, specifically multiplying fractions together. So we did the top times top and the bottom times bottom when we were multiplying fractions. In this video, we're going to talk about dividing rational numbers, specifically dividing fractions. And before we do that, we need to talk about this concept of a multiplicative inverse, or otherwise known as a reciprocal. Now, multiplicative inverses or reciprocals are two numbers that have a product of 1. So when you multiply them together, you get 1. And that's an important thing that we're going to need to know to help us divide fractions. So if you'll look at the example down here in this pink box, I have an example of multiplicative inverses here: 2/3 and 3/2. When you multiply these two together, you multiply the numerators, you multiply the denominators, you get 6/6, which is 1. So really, they're kind of like mirror images of each other. They're not opposites, but they're called reciprocals. So when you multiply them together, you get the same thing in the numerator that you do in the denominator, which is always equal to 1. So we're going to be using this concept of reciprocals to help us divide rational numbers. So let's just practice on these numbers here. Let's find the multiplicative inverse of each number, or the reciprocal of each number. It's really easy to do. You just basically take the fraction and flip it over. So the reciprocal, or the multiplicative inverse, of 7/16 is 16/7. I just flip that fraction over, and the numerator and the denominator exchange places. So you can see that if we multiply these together, I'm going to have 7 times 16 in the numerator and 16 times 7 in the denominator, which is going to be the same thing. So that's going to equal 1. The next one, -5/9, the reciprocal of a negative fraction is still going to be negative. And I'm just going to flip that fraction over. It's going to be -9/5 would be the reciprocal, or the multiplicative inverse, because a negative times a negative is going to be a positive. And then again, I'm going to get the same product in the numerator as I do in the denominator. It's going to be 45/45, which is equal to a +1. Next, we've got some mixed numbers, 2.5. So what's the reciprocal, or the multiplicative inverse, of a mixed number? Should we just flip the fraction part over? No, we can't do that. We actually have to rewrite 2.5 as a fraction first, and we learned how to do that in this chapter previously. So 2.5 as a fraction is 5/2. So now that we have it in fraction form, we can actually find its reciprocal or its multiplicative inverse. We'll flip that over, and it's going to be 2/5. So the multiplicative inverse of 2.5 is 2/5, because when you multiply them together, you're actually going to get 1. And then the same goes for -6 1/3. I'm going to have to write this as a fraction first. So -6 1/3 as a fraction is -19/3. And then if I just find the reciprocal of that, it's going to be negative still. -3/19 would be the reciprocal, or the multiplicative inverse of -6 1/3. If you multiply those together, you're going to get a +1. Now, why do we talk about that? Because we need to understand the concept of a multiplicative inverse so that we can learn how to divide fractions efficiently. So long story short, to divide a fraction, we're going to actually multiply by its multiplicative inverse. We're not going to actually divide the fractions. We're going to multiply the first fraction by the multiplicative inverse of the second fraction. Kind of like when we were adding integers and subtracting integers. We didn't really subtract integers, we could add the opposite. Well, this is a very similar concept. We're not going to divide the fractions. We're going to multiply by the second fraction's multiplicative inverse, or its reciprocal. And I've got a proof of that down below. It looks kind of confusing here, but bear with me. I'll explain why this works. So if we take this example of 4/9 divided by 3/5. Well, I'm going to rewrite this division problem in fraction form here in that second step. So all I did was just write it as a fraction, 4/9 over 3/5. So that's kind of the same thing. They're a ratio. So we're talking about division of these fractions here. Now, one thing we can do with fractions is we can multiply the numerator and the denominator by the same thing, and it won't change the value of the fraction. So what I did was I multiplied the numerator and the denominator by the reciprocal of the denominator. That's going to make the denominator 1, and it's basically going to get rid of the fraction. So I multiplied the top and the bottom by the reciprocal of 3/5, which is 5/3. Now what's going to happen in the denominator? What's going to happen here when I multiply these two fractions together, I'm going to get 15/15, which is just 1. So the denominator actually becomes 1, and we know that a fraction with a denominator of 1 is basically just whatever the numerator is. So this is equivalent to 4/9 times 5/3, and that's how I get this last box here. So if we kind of put the beginning and the end of this train together, these are all equivalent. So the first thing in the string, 4/9 divided by 3/5, has to be equal to the last thing in the string, which is 4/9 times 5/3. So you can see that this division problem is equivalent to this multiplication problem. All we have to do is multiply by the reciprocal of the second fraction, and they're going to be equivalent. You're going to get the same answer. We already know how to multiply fractions, and it's very simple to do, so why not use that to our advantage when dividing fractions? So let's put this into practice here. I have 1/3 divided by 7/15. That's actually going to be equivalent to 1/3 times the reciprocal of 7/15, which is 15/7. And I can do a little bit of simplifying here before I multiply. These are both divisible by 3. 3 divided by 3 is 1, and 15 divided by 3 is 5. And that gives me 5/7, and that is in simplest form. So 1/3 divided by 7/15 is actually 5/7. You can check that on your calculator just to make sure. I'm pretty sure that turns out to be correct. Next one, 5/8 divided by -3/4. Again, I'm not going to divide these fractions. I'm going to multiply by the reciprocal of the second fraction. So the reciprocal of -3/4 is -4/3. So I just flip that second fraction over, and now I can multiply. I do have some common factors again. 4 and 8 have a common factor of 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So when I multiply these, 5 times 1 is 5. And 2 times 3 is 6. And this was a positive times a negative. So it's -5/6. Don't forget your negatives in there. It's easy to overlook those things when multiplying or dividing our rational numbers. Next one here, -6/7 divided by 12. Well, what's the reciprocal of a whole number? This isn't really a fraction. Well, if you'll recall, we do know how to write a whole number as a fraction. We learned how to do that. We'll just put it over 1. So what would be the multiplicative inverse, or the reciprocal of 12 over 1? Well, it would be 1/12. So I have -6/7 times 1/12. And again, I've got common factors. 6 divided by 6 is 1. 12 divided by 6 is 2. And when I multiply these together, 1 times 1 is 1. 7 times 2 is 14. And this was a negative times a positive, so it's -1/14. Last one here, I've got two mixed numbers. So how I'm going to divide these mixed numbers, I'm going to change them to improper fractions first, or to fractions first. So 6 3/8 is equal to 51/8 divided by 4 1/4 as a fraction is 17/4. And then again, I'm going to multiply by the reciprocal. So I have 51/8 times 4/17. And I do have common factors here to kind of knock these numbers down a little bit. 4 and 8 have a common factor of 4. 4 divided by 4 is 1. 8 divided by 4 is 2. And then actually 17 and 51 have a common factor of 17. 17 divided by 17 is 1. 51 divided by 17 is 3. And that makes my multiplication quite easy to do. 3 times 1 is 3. And 2 times 1 is 2. So I have 3 halves, or I can write that back as a mixed number, 1 and 1/2. So that's using the multiplicative inverse, or the reciprocal, to help us divide fractions. We're actually going to turn it into an equivalent multiplication problem. What happens if we have variables in our fractions that we're dividing? We're still going to do the same thing, but remember that those variables are factors, so they can cancel just like numbers or common factors would. So this is going to become 5ab over 6 times the reciprocal of 10b over 7, which is 7 over 10b. And I do have common factors here. 5 and 10 have a common factor of 5. 5 divided by 5 is 1. 10 divided by 5 is 2. And I also have a common factor of b. b divided by b is 1, and b divided by b is 1. So I have 1 times a times 1 times 7 in the numerator, which is 7a, and 6 times 2 times 1 in the denominator, which is 12, and that is simplified. There are no common factors in numerator or denominator, so my result, or my quotient, is 7a over 12. We're just going to treat those variables just like factors. And then the last one, mn over 4 divided by m over 8, again, I'm going to multiply mn over 4 times the reciprocal of m over 8, which would be 8 over m. And again, I have common factors. 8 and 4, again, gives me 1 and 2. And then my m's. M divided by m is 1. So I have 1 times n times 2 in the numerator, which is 2n. And 1 times 1 in the denominator, which is 1. So I have 2n over 1, which is just 2n. And there is my quotient. So dividing fractions, we're actually going to use what we know about multiplication. We're going to multiply by the reciprocal, or the multiplicative inverse, of the second fraction.